So I'm going to also introduce this year's Douglas Ruth Memorial Lecture, and we're very proud to award this lecture to Dr. Soheil Asgarpour, now our immediate past president. Dr. Asgarpour is a fellow of the CIE, the Canadian Institute of Mining, Metallurgy and Petroleum, CIM, and the Canadian Society of Senior Engineers, CSSE. Dr. Asgarpour has over 35 years of diversified technical, business, and operations experience in the oil and gas industry, marked by providing strong leadership to several profit and not-for-profit organizations. Soheil has served Petroleum Technology Alliance Canada, PTAC, as president since 2007 and is now president and chair. Prior to joining PTAC, Soheil successfully led the overall management of the Crown's oil sand interest in his position as business leader of oil sands for the Alberta Department of Energy. Prior to working for the Department of Energy, he held executive positions with mid and large-size oil and gas companies. Soheil earned his PhD in mechanical engineering from Rice University in Houston, Texas. He completed the Western Executive Program at the Western Business School, the University of Western Ontario, and the Leadership Program at Yale University. He currently serves our industry in several capacities as immediate past president, obviously, of CIE, as a board member of the Council of Canadian Academies. He has previously served as first vice chairman for the Petroleum Recovery Institute, president of the Canadian Institute of Mining, Metallurgy and Petroleum, CIM, as chair of the Petroleum Society of CIM, and the Canadian Institute of Photonic Innovations, and as a director of Clean Resources Innovation Network. He's a life member of the Society of Petroleum Engineers and a member of CIM, CSA, CSSE, CIE, Association of Professional Engineers and Geoscientists of Alberta, and the Institute of Corporate Directors. Clearly, we're very fortunate to have such an accomplished and illustrious speaker for this year's Douglas Ruth Memorial. Speak. Over to you, Soheil.
Well, thank you very much, Catherine. I really appreciate that. Just one little correction. I'm not a chairman of PTAC. I'm a president and CEO. But thank you very much for this.
Well, maybe you'll be the chair next time. Thank you, Soheil.
So let me start with this kind of first slide. As you can see, this memorial lecture is dedicated to honoring the legacy of Dr. Douglas Ruth. We pay tribute not only to his remarkable achievements, but also to his values and principles. Doug was not merely an individual of extraordinary talent. He served as a beacon of inspiration to all who cross his path. His tenure as a president of the Academy was marked by remarkable service, leaving an everlasting mark on the Academy and its fellows. Sustainability was his passion, which compels me to delve into the critical topic of mitigating methane emissions, paving the way to net zero. So may I have the second slide? In today's discussion, I will present two interconnected topics. The first one, I would like to delve into methane detection, measurement, reporting, and mitigation in oil and gas operations. I will elaborate on the ecosystem we cultivated, featuring the development, field testing, demonstration, and commercialization of 89 technologies. These innovations have played a pivotal role in reducing 45% of methane emissions from oil and gas operations in Canada, positioning the country as the global leader in reducing methane emissions. Additionally, we will discuss strategies to support increasing technology capacity, facilitating the oil and gas industry's journey towards achieving a 75% methane mitigation target by 2030. Secondly, we will explore mitigation strategies for methane emissions from natural sources, aiming to significantly contribute to achieving net zero targets. I have a slide 3. So let's get a kind of picture of this business of methane. Methane, as you know, is odorless and colorless, out of sight, out of mind. So for many, many years, nobody paid any attention to it. But things change, and the reason it changed is an image that you can see here, created essentially by satellite, that the sensors detected methane emissions, and then they show the situation that we are dealing with. So it was around 4 or 5 years ago, we started paying attention to this business of methane emissions. And to the point that now globally people realize that 30% of greenhouse gas emissions and impact of climate change is coming from methane alone. And that is actually, when you look at it, that's on a 200-year period. If you look at the next 10 years, the impact is actually 4 times bigger because of the residence time of methane in the atmosphere. So what happened, we at PTAC knew the negative impacts of methane emissions much, much earlier. This is why we launched the first consortium to reduce methane emissions in 2008. And in the context of oil and gas operations, methane emissions are often associated with VOCs, volatile organic compounds, posing health risks such as cancer. So when we are talking about methane reduction, we are not just talking about the greenhouse gas emissions that we are going to reduce, but we are also talking about reducing health bill, but we actually, rather, by conserving, we would sell methane as a valuable commodity. So the other element of methane is this aspect of clean tech. Methane also serves as a bridge between leading edge clean tech and traditional oil and gas sector. This has really opportunity for Canada to, as a leader now, to expand its activities on methane emissions reduction and technologies, and be able to be a leader in a clean tech, which actually is supposed to be become one of the largest industry, even surpassing information. As we reduce methane emissions from Canadian oil and gas, we are going to end up with clean or cleaner oil and gas, and that would enable producers to also demand higher premium for what they have. So since 2008, our consortia have created 89 technologies. Just our first technology alone that was field tested in 2008 is currently reducing emissions equal to taking 140,000 cars off the road annually while saving $20 million per year in energy costs. So may I just move to a slide, the next slide. This slide shows the various global sources of methane emissions. Wetlands rank as the primary global methane source, with permafrost leading in Canada. So in Canada, wetlands are number 2. Natural sources of methane emissions account for over 40% of total methane emissions globally. with agriculture being the largest man-made source of methane, followed by oil and gas and landfills. So the other thing to say is that total methane emissions from natural and anthropogenic sources contributes 30% of global greenhouse gas emissions over a 200-year period. But as I mentioned, on a shorter time frame, with the impact over a decade, is actually 4 times bigger. A reduction of methane emissions offer a crucial opportunity, as mitigating emissions from natural sources of methane can offset all man-made greenhouse gas emissions over a 10-year period. This provides a vital window for transitioning to cleaner fuels while devising practical solutions for reducing other greenhouse gas emissions. So may I move to slide number 5, please? This slide shows various sources of methane emissions from oil and gas operations in Alberta in 2018. The picture has drastically changed because many of these sources that you can see, we have already addressed and reduced their emissions significantly. So in general, these emissions are coming from 2 sources. The first group we call it essentially fugitive emissions. These are unintentional sources of methane emissions. Leaky valves, flanges, etc. are part of these categories. And of course, the solution is pretty simple. We can detect those and go repair it very quickly. The second sources are intentional, and we call it venting. So this would be including oil and condensate tanks, pneumatics, and chemical pumps, etc. And the bottom line is that in oil and gas, we use many devices to run small engines and other things. And the way they work, they essentially use the pressure of natural gas. And by reduction of pressure, they create this energy that runs those engines. And then the methane is vented into the atmosphere, which is creating significant greenhouse gas emissions. So, so again, as I mentioned, those 89 technologies provided many of them economic solutions for both fugitive and venting sources. So let's move to slide number 6. So to find solution in reducing methane emissions, in 2018, we set a short-term goal to build enough methane mitigation technology capacity by 2022 to enable producers reduce their methane emissions by 45% by 2025. And we wanted to do it at a cost of less than $5 per ton of CO2e. So that was kind of the target that we set. Well, I'm kind of really pleased to say that not only we met this target and increased the capacity by 48%, but we did it a year earlier in 2021. The early technology adoption by industry also, along with regulations, I would say good regulations, and also incentives provided by various governments, allowed producers to meet their 45% target already. So one of the successes that we had about this one is we brought everybody together, policymakers, regulatory bodies, producers, technology providers, transporters, academia, etc., to work together toward solutions that we all were working towards. Our long-term vision is to increase technology capacity by 90% by 2030 to equip industry to reduce its emissions by 75% by 2030. So let's move to slide number 7. So in 2018, we completed a roadmap which concluded that we had a fragmented innovation ecosystem. So since then, our focus has been on fostering a cohesive ecosystem and aimed at connecting individuals, ideas, projects, capital, and technologies through massive collaboration. So at the heart of this endeavor are over 400 producers who voluntarily contribute funds for our applied research program. And that's kind of far on the right side on the top. And this program essentially provides best practices to producers. But because of participation by regulatory bodies and policymakers, which use the peer-reviewed applied research that are kind of coordinated by PTAC, then they would use it for development of their intelligent regulations and policies. Additionally, when you move to the far, maybe left on the field testing side, 14 committed producers in collaboration with 16 universities have provided over $1 billion in lab and field testing facilities to enable us at no cost to the technology providers field test their technologies. And that overcame what we call the valley of death situation for SMEs. Moreover, regulatories and policymakers, as I mentioned, they have joined this kind of ecosystem. There are, as I mentioned, over 400 producers. There are 100 technology providers part of this, and numerous other stakeholders that they work together toward the same goal. Our network operates in collaboration with the Clean Resource Innovation Network. We have partnered with NRCan, with Alberta Innovates, with Alberta Environment and Protected Areas, and numerous government organizations that they not only fund our programs, but as I mentioned, they directly are involved with those research and technology development. We run programs specifically tailored to assist small and medium-sized enterprise with market fit analysis, that's on top right, aiding them in field testing, commercializing, and enhancing the market uptake of their technologies. Various consortia are in place to develop, as I mentioned, lab and field tests. And also there are consortia to demonstrate technologies. That's shown on the left side of this graph. Furthermore, our consortia pay up to 75% cost of equipment and installation to provide first-hand experience with various technologies to producers, thereby increasing the market uptake of Canadian technologies. And that is shown on the left side of this graph. There are numerous programs facilitate the export of Canadian technologies abroad, such as trade missions, a directory of Canadian technologies and services offered by SMEs, and other programs that essentially would help us not only help SMEs with increasing their uptake, but also educating them with the challenges that they may have in international markets and guide them in terms of how they can overcome those challenges. So let's move to slide 8. So this is showing essentially a series of methane detection technologies that have been demonstrated through PTAC, utilizing various technologies, including super sensitive sensors that they have been deployed on various platforms such as airplanes, drones, trucks, and stationary stations. And then we complement these sensors and the results that we get from them through using statistical, analytical, and AI machine learning softwares, not only interpreting the gathered information, but also using it as a tools to predict behaviors and predict what we would expect. So if we move to slide 9, that shows one of the largest projects that at the time that was done, globally done to detect methane emissions. So in an area of over 2,500 square kilometers, we had over 200 large facilities operated by 30 operators. And we wanted to go and measure their methane emissions equipment by equipment. So I sent a letter to all of the CEOs of these 30 companies, and I said, I need access to your facilities. And 29 of them said, you are welcome, come. One of them said, well, we are not sure if you are authorized to access our facilities. So I sent them the second letter saying, the regulatory body deputized us that we have access to your facilities. So they said, come and work. So anyways, what we did, we went there and measured emissions. And the whole idea was we wanted to learn several things. Number one, what was the optimum frequency that we have to go detect these methane emissions to get a good handle in terms of management of it? The second was, what type of technologies can we use? And so with this one, we were using essentially optical gas imaging, high flow sampler, etc., QOGI, and we repeated this on many, many frequencies. Sometimes we wouldn't even let know about if we have detected anything from their facilities to measure to see how effective this approach will be in terms of detections of methane emissions. The next slide, please. The next big area that we did, this was done essentially in a different area, again, 2,500 square kilometers. But now what we try to do here, combine a bunch of technologies together to see how by combination of technologies we could, number one, increase the accuracy, and number two, bringing the cost down. So the technologies that we were using various sensors, but also we're using mounting them versus on drones versus airplanes versus trucks and other things, and then trying to see how effective they were measuring in really harsh environment, when it was snowing, when it was wet, and then trying to see which one worked, which one didn't work. And that gave us a very good idea in terms of how we can combine technologies to come with more accurate measurement of methane emissions. May I have the next slide, please? So as I mentioned, we had this valley of death situation. And the valley of death is referring to inability of SMEs, a small and medium-sized enterprise, in securing sites and also funds to do their field tests. So in 2008, as I mentioned, we started with the concept of consortia. Till 2018, we used this concept by launching numerous consortia to field test their technologies. But it was cumbersome, it was extremely difficult. You have to knock at many doors to get a site or funders in place, etc. So I thought maybe we should probably change the model and came with this idea of creating a field testing facilities. And that's why I approached by then 16 producers that they agreed to provide us sites, and also 16 universities, 2 of them were in the US, to provide their lab facilities. Those 16 producers now are 14, 2 of them merged essentially with others, but they provided over $1 billion facilities. I approached NRCan and also Alberta Innovates, and they agreed to provide us with the operating cost to do these tests. And this generous offer from producers, from researchers, and government enable us at no cost to field test and lab test their technologies. And that is how the capacity went up. So may I have the next slide? So these facilities are from East Coast to West Coast, coast to coast to coast. Majority of them, of course, in Alberta due to the intensity of facilities there. But many of them are, you can see they are in Eastern Canada and also far Western Canada. May I have the next slide, please? So this 89 technologies, not all of them done all things, being technology development, field testing, demonstrating, commercializing. But several of them, we did it all for them, but majority of them either were only focusing on field testing or demonstration or, for example, commercialization. And now these 89 technologies, as I mentioned, they have capacity to reduce methane emissions by 48%, and they have played a major role in the actual reductions of methane emissions. May I have the next slide? So what I tried to understand or demonstrate was the impact of these technologies. So I thought the best thing would be to define what I call intensity of methane emissions. So the way I defined it was methane emissions per 1,000 barrels of oil equivalent. And that becomes intensity. And I wanted to plot this. As you can see, this plot shows on the x-axis the time that we field tested or lab tested or commercialized various technologies. It shows the total BOE per day and also shows the intensity as we defined. So what this shows actually that before even putting any big target from government or any regulations or policies in place, we saw significant reduction of methane intensity due to early adoption by producers, that they felt that these technologies were economic and they deployed them. Now, again, on this graph, what you can see the intensity actually were flattened in some areas. And then the question is, why did it flatten? And then the answer is actually the way that, for example, Alberta government and the federal government were measuring methane emissions, they were using engineering calculations. We now know that methane detection, the actual methane detections by sensors, etc., is indicating higher emissions. So government organizations are gradually, what they are doing, they are flattening that emissions by applying those technologies. So moving forward, I think in the next slide, what it shows. No, may I go back to the previous slide? These are the sources, 6 sources of methane emissions that we need to solve the problem to get to the 75%. What we have done so far, there have been technologies that they were essentially commercial and they were low-hanging fruit. Now we are moving to much more complex situations and technologies that essentially would be more costly and more difficult to come up with solutions. So let me go to the next slide. I mentioned about the situation with the wetlands, permafrost, and other things, that these are huge sources of methane emissions. So one potential solution is what we call oxidizing essentially methane. And by doing so, then we would be able to solve the problem by capturing methane from permafrost and wetland. Still, a huge amount of work is required to be done to be able to measure them, to know exactly how much they are. But here is the test that we did is with less than 0.5% of methane being in the air. And then we wanted to eliminate that. And the technology, as you can see, started heating up with kind of something that we could just start. But once the whole system would start working, then you wouldn't need that, and then the whole system would do it by itself. So you started at entering 18 degrees centigrade, and as you move down, the temperature goes up. Partly is because when the temperature for the flow to go out is heating up the right side. And then at 900, approximately 50 degrees centigrade, you have the complete oxidation. But the oxidation starts even at lower temperature and gradually increase the temperature of the flow as well as we are moving to that. This technology could be used if we have the concentration of methane higher than 0.5%. So let's move to the next slide. I think it seems that I'm getting the indication that I'm running out of time because my slides are moving fast. So I think the conclusion is essentially is a summary of what I have said in my presentation. I would be more happy to answer any questions that you may have.